To solve equations with fractions, we have to know what a term is. So with this first equation, x on 6 is a term, the minus 1 is a term, and 3 is a term. Now, with fractions in equations, we actually don't want them. So I'm going to try and get rid of this 6. The opposite of dividing by a 6 is multiplying by a 6. But whatever I do to one term, I have to do to all the other terms. So I also have to multiply 1 by 6, and I have to multiply the 3 by 6. Now, the 6's cancel, because 6 into 6 goes once. Then on the left-hand side, I'm left with an x minus 1 times 6, which is 6, 3 6's, which are 18. And then it becomes the more simple equations. So then the opposite of minusing 6, adding 6. So I'm left with x equals 18 plus 6, which is 24. So the answer to my equation is x equals 24. Remember, when you solve an equation, you have to end up with x equals. We'll do a few more examples similar to the first one. So x plus 7 divided by 4 equals 8. I've got a 4 on the bottom, but I don't want it there. So the easiest way to get rid of a divide by 4 is times by 4. And whatever I do to one side, I do to the other. 4 into 4 goes once, so the 4's cancel. On the left-hand side, I'm left with x plus 7 equals 8 times 4, which is 32. I don't want the 7 with my x, so I get rid of that. So I'm left with x equals 32 minus 7, which is 25. This equation has got two different denominators, a 5 and a 4. Now, to get rid of both of those at the same time, we multiply them by a number that both 5 and 4 go into. The smallest of that is 20. So I'm going to multiply every term in my equation by 20. Now, when I do that for the first one, 5 into 5 goes once, 5 into 20 goes 4, and then 4 into 4 goes once, 4 into 20 goes 5. So this first term now becomes 4 times 3x, which is 12x. The second term becomes 5x, x times 5, and then the other side is 20. 12x minus 5x, collecting like terms, is 7x, equals 20. The opposite of timesing by 7 is dividing by 7. Whatever I do to one side, I must do to the other. The 7's cancel, and I'm left with x equals 20 over 7. It's best to leave it as a fraction rather than a decimal, because the fraction is the exact answer. They do get a little bit harder again. This one has got 4 separate terms, 2 different denominators, 5 and 2. To get rid of both of those, I have to multiply the whole equation by a number that 5 and 2 go into. The smallest one of those is 10. So I'm going to times this term by 10, and this one, and that one, and the 4. When I do that, start cancelling. 5 into 5 goes once, 5 into 10 goes 2. So this term I'm left with 2x. 1 times 10 minus 10. Now this is where it gets a little bit trickier. 2 into 2 goes once, 2 into 10 goes 5. So I might leave that 5 out the front, but it has to multiply with everything on top of the fraction. So the 5 has to multiply with 3x minus 1. And then the last term plus 40. Tidying that up a bit, the left-hand side stays the same, but the 5 has to multiply with 3x to give me 15x, and then the 5 has to multiply with the minus 1 to give me minus 5. So 2x minus 10 equals 15x plus 35. I'm going to get the x's onto the same side, so I'll get rid of the 2x, but whatever I do to one, I do to the other. So I'm left with minus 10 equals 13x plus 35. I don't want the 35. Subtracting those, minus 45 equals 13x. Then I've got 13 times x. I want x by itself. Divide both sides by 13. So I'm left with x equals minus 45 over 13. One last example. Denominators are 3 and 4, so I need to times everything by 12. Then see what I can cancel. 3 into 3 goes once, 3 into 4, 12 goes 4. So then for this term I'm left with 4 outside of x plus 2. Then going to my next, 4 into 4 goes once, 4 into 12 goes 3. Then I've got minus 3 lots of x minus 5, which equals 6 12s, which is 72. Expanding the brackets, 4 times x, 4 times 2, 3 times x, minus 3 times x, then minus 3 times minus 5 is plus 15. Collecting like terms, 4x minus 3x is x, and 8 plus 15 is plus 23. Don't want the 23. So x equals 72 minus 23, which is 49.